Section 3 in Chapter 3 is about temperature. So there are 3 different temperature scales that we use: Celsius, Fahrenheit, and Kelvin. Celsius is the most commonly used in science. Fahrenheit, you of course recognize because we use Fahrenheit for weather temperatures, and a Kelvin is the SI unit for temperature. So first, let's talk about Celsius and Fahrenheit. So the reference points for Celsius are the boiling point and the freezing point of water. So for water, the boiling point in Celsius is 100 degrees C, and the freezing point is 0 degrees C. In Fahrenheit, the boiling point of water is 212 degrees Celsius, or Fahrenheit. I wrote degrees C accidentally. So these are degrees Fahrenheit. And then the freezing point of water is 32 degrees Fahrenheit. So if we take a look at the difference between the freezing point and the boiling point of water for each temperature scale, for Celsius there's a difference of 100 degrees Celsius, and for Fahrenheit there's a difference of 180 degrees Fahrenheit. So that means 180 degrees Fahrenheit is equal to 100 degrees Celsius because they're both the difference between the boiling point and the freezing point of water. So we can reduce this down and we get 1.8 degrees Fahrenheit equals 1.0 degrees Celsius. Okay, so this relationship between Celsius and Fahrenheit is how we get our equation. So the equation for Fahrenheit is, or to convert from Fahrenheit to Celsius, or vice versa, is the temperature in Fahrenheit equals 1.8. So there's our ratio that converts our temperature from Celsius to Fahrenheit, and then we adjust for the freezing point with the 32. So we have to add 32. So this is our equation, and this would convert our temperature from Celsius. So if we're given a temperature in Celsius, we can convert it to Fahrenheit using this equation. But what if we're given a temperature the other way around? So let's say we're given a temperature in Fahrenheit and we want to find the temperature in Celsius. So we would need to rearrange this equation to solve for the temperature in Celsius. So first we would subtract 32 from both sides because we want to get temperature in Celsius by itself. So the 32, a positive 32 and negative 32 cancel, that goes to 0. So now we have temperature in Fahrenheit minus 32 equals 1.8 times temperature in Celsius. So now we can divide both sides by 1.8. So the 1.8 cancels. We have the same thing in the top and the bottom, and that means that value goes to 1. So now we have our temperature in Celsius equals, so I'm writing it the other way, temperature in Fahrenheit minus 32 divided by 1.8. Okay, so now we have an equation for each. So depending on what temperature scale you're starting with, you can use either one of the equations. And as long as you remember how to rearrange it, you can get this equation from this first equation. So we'll call this equation 1 and equation 2. Okay, so next we'll talk about the Kelvin scale. So scientists have figured out that the coldest temperature possible is negative 270 3 degrees Celsius. So on the Kelvin scale, this is considered absolute zero. So that is 0 Kelvin. Okay? And if we look at our reference points again, the boiling point of water and the freezing point of water, if we find the difference between those two values, the boiling point of water is 373 degrees Kelvin minus the freezing point of water is 273 degrees, or 273 Kelvin. There's no degree symbol for Kelvin. It's just a K is the unit, capital K. There's a difference of 100 Kelvin. So that means that there is a difference of 100 Kelvin, which is equal to 100 degrees Celsius. So 1 Kelvin equals 1 degrees Celsius. Okay, so we can find our equation. We can convert from Celsius to Kelvin by just adding 273. So the temperature in Kelvin is equal to temperature in Celsius plus 273. And this is because we know our freezing point of water is 273 Kelvin. So we're just accounting for the freezing point. Okay? So this is our equation to convert from Celsius to Kelvin. Okay, so we'll look at some examples of scale. So normal body temperature, you guys all know 98.6 degrees Fahrenheit is normal body temperature. In Celsius, that is 37.0 degrees C. And in Kelvin, it is 310 Kelvin. So that just shows you a little bit of the difference between the three temperature scales. Okay, so now we'll do a practice. So this is really more unit conversion, but in this case we have specific formulas that will take us between the three different scales. So in this example, we're going to convert 21 degrees Celsius to Fahrenheit and to Kelvin. So let's convert it to Fahrenheit first. So we have our equation, temperature in Fahrenheit is equal to 1.8 times the temperature in Celsius plus 32. Okay, so just commit this formula to memory, write it down somewhere, you'll be able to use it on your exam. So first, we're going to plug in our temperature in degrees C that they gave us. So they gave us our temperature, and we need to go, or they gave us temperature in Celsius, and we need to go to Fahrenheit. So if we plug our number in, temperature in Fahrenheit equals 1.8 times 21 plus 32. So if we do that math and work it out, then we get an answer of, so 1.8 times 21 is 38 plus 22. Okay, so if we add those two numbers together, I'm sorry, 38 plus 32, not 22. I just copied it down wrong. So 38 plus 32 equals 70. So let's look at our sig figs. So 1.8 and 32 are exact numbers. So those don't count towards sig figs. So we started with 21. That number is really what determines our sig figs. So 21 times 1.8, we would use two significant figures. So that would be these two significant figures here. And now we need to look at the decimal places. So there's no decimal places in our answer there. So there would be no decimal places here. But we need to show that this 0 is significant because our last sig fig would be the ones place. So we need to put a decimal. So our answer is 70 decimal degrees Fahrenheit. Okay, so that is 21 degrees Celsius converted to Fahrenheit. So now let's also convert to Kelvin just for some practice. So the temperature in Kelvin is equal to temperature in Celsius plus 273. So this formula is really easy to remember, and you will know it quickly if you do any practice problems. So we'll plug in our number that they gave us, the 21 degrees C, plus 273. So again here, we need to look at our sig figs. 273 is a measured number. So they measured the coldest temperature that they could possibly reach. So this 273 is measured, so we need to include it in sig figs. But in this case, we have no decimal places on 21 and no decimal places on 273. So our answer should have no decimal places. So if we add these together, we get 294 Kelvin. Okay, so there are our two answers for that example problem. And that's all it takes to convert between the three temperature scales.